We're here to talk about shaders. Basic questions first. Do you know what shaders are? I explained this to you already, but I don't know if you two got it. You already got it, so you won.
Let's let the audience.
Let's enjoy. Okay.
Raise your hand.
Give it for the audience. All right. All right. Fact is that most computers, definitely our desktops, all of our console machines, they all have many more than just what is considered the one CPU. There are a whole mess of processors in every computer. Most of the time, we usually separate it into the concept of GPU, graphics processing unit, from your CPU, which is the one that everybody does all the specs about. But the fact is that the GPU, the graphics side, has just as much processing power, if not more, than the main machine. It is simply specialized to handle what is needed for graphics rendering. It actually happens in a set of stages, and those stages begin with the original geometry that you send to the machine saying, okay, I have a coin. Simple. There in this coin, it defines possibly a texture. It defines all the points that define how this will, the starting shape. I specifically say starting shape because we'll get into some ways where you can change that shape as you go. And some textures to define, ooh, here's a picture on one side, here's a picture on the other, different pictures. Those are textures. You guys already know all that. The important thing is that the geometry is sent to the graphics hardware, and then the first step is what is called a vertex shader, where it takes all of the points and allows you to do pretty much anything you want with them. The important bit about that is that when we send what we call a three-dimensional object into the graphics system, the very first step is to flatten that three-dimensional view into the two-dimensional screen. So all of our perspective transformations, all of that occur in the vertex shader. It takes every point, does a little bit of math on it, or a lot of math, depending on what you want to do, and sends that off to the next chunk to do the actual rendering. The actual rendering breaks down every polygon and does what is a scanline conversion, so that every single point is then looked at, and they usually call these points fragments. Every pixel of the screen is, they call it a fragment. And they run that through a second shader, and that is the fragment shader. That's where you tend to do a lot of lighting calculations, any other kinds of cool whiz-bang things you want to do. That includes texture lookups. All of that happens, most of that happens typically in the fragment shader. You can, in some hardware, do texture lookups in the vertex shader, but that's besides the point at the moment. Commonly, it used to be fixed function, where none of this could be controlled at all by anybody but the hardware. You had a certain set of flags that you were allowed to turn on. That was it. No programming involved. That was when we had the fixed function pipeline, before we had the option to truly program these machines. Thanks to the ability of these programmable machines, we can actually do full ray tracing completely on the GPU. We can even make use of the GPU like it is a second computer, a second main processor. That's the OpenCUDA project, that sort of thing. Incidentally, Unity has somewhat support of that, but that's besides the point.
Pique my interest though. CUDA, that's NVIDIA specific though, right?
That is NVIDIA specific, yes, but there is the DirectX, I think it's DX11 geometry shaders that can do the very same thing. And incidentally, Unity supports shaders that are built for DX11 so that you can use it for general purpose calculations and get that information back.
So you could essentially write a function that would then call out to the GPU, do a calculation,
and bring it right back into the main
separate thread that would.
Yes.
Okay. Nice.
Yeah, you can. There are many of the mainstream physics simulation engines use that now within their engines. They have the actual processing for the physics done in the GPU, brings it back into the CPU, and then makes use of the information. Okay, as an example of this transformations possible in the vertex pipeline, there I have a project where you start with your plain old geometry, but you start messing with that geometry to make interesting effects. Where I started with this project was looking at Animal Crossing, I think it is, where as you get farther away from objects, they seem to curve off the world to get out of view, rather than having a very large view. This was by taking a simple geometry, and looks pretty normal when you're close up. This is because this is before any shaders.
Is this the expected slide? Right.
Yes.
Okay.
This is before any shaders are applied. Looks perfectly normal. You see everything you would expect to see. Everything moves the way you expect it to move. But all you have to do is switch to a special vertex shader, and the world gets a little weird. Now, in the physics system,
That's
I see
been
what
up
you mean.
there for a while.
Doop-de-doop. Hello, Unity. That's what I get for not practicing enough. Hey, don't go over there, go over here. I like you over here. There we go. Hi. Well, now you get to see the after effect. Where the world falls away. The physics engine, everything else about the game, still is acting on originally three-dimensional, typical, plain old objects. But because of the shader, it looks like the world is falling away from you.
Reminds me of the Sonic's hidden levels.
Yeah.
With the ball. Yeah.
It's similar to, what the hell is that name?
And this is done strictly in vertex shaders.
Cooking one.
Incidentally, because of how Unity does their shaders in...
So you're sending the full 3D information to the shader, and it flattens it. But before it does that, it does vector processing against it.
No, the vector processing is the flattening.
Right. Okay. But that's why you're able to get the bottom side of the trees, because you sent the full 3D information in.
Yes.
Snake. That's a snake. I don't even know. But the whole world is like that. Like as you go along, it just like curves. It's pretty fun.
I'm getting closer and closer to the floor, and you can
Mario
see.
Galaxy, I think.
So, that is how shaders, the basics of how a shader works. Goes through those two different phases. Now then, so what are we trying to make here? And we're going to be doing an example of the rendering used on this sword animation, where it takes the background and messes with it. It doesn't actually change the colors of the background, but it ripples the background by shifting it around a little bit. Very obvious in case the notice. All right. Now we're going to get into actually doing this. Where is my screen duplication? I don't see it. Well, let's go find it. This will take me just a moment. Okay. And now you can see what I see.
All right.
So, we're going to start with a clean project that has nothing in it yet. And I'm going to open up my notes. And you're not going to look at this. See? Not going to look at it. Can't see it. Can't see it. Ha. All right. I have a basic world. All of these resources are out of Unity's one of their default asset packs. Very useful for prototyping. A lot of good stuff in here. I literally just took one of their scenes and said, go with it. And that one scene had all of this in it: character, world, things to interact with, like these blocks over here, these gray blocks. You can interact with. Lots of useful stuff for you to get a feel for what your game could be like. I highly recommend using things like this where possible, because in Unity, getting the game to feel right is the hard part. Reskinning it is stupid easy. So, we start there, and we're going to make a couple of objects to show off this new effect. So, nothing you haven't seen before. Make me a capsule. Make me a cube. And let's move that over here. You're not scrolling. Scroll for me. Scroll. Okay. Now, I'm going to parent these on the character, because now when I move the character around, they're going to follow, as opposed to if I had put it attached to the camera itself. Nope, that's not what I'm looking for. That's what I'm looking for. Because if I had attached it to the camera, then those two things, no matter where I am in the world, where it's always going to be right there in the camera. Pretty boring. Not that exciting. So, I'm going to put it on the character, and they're going to move with him, not necessarily with the camera. Okay. Okay. Now that they won't get in my way. Alright. From here we're going to create a new shader and a new material. In Unity, a shader is only used if it's attached to a material. The material is what you attach to a particular thing to render it. This is all core Unity stuff. Nothing really exciting here. So I'm going to go ahead, create my shader, not the compute shader. Incidentally, that compute shader is what I was referring to for the CUDA stuff, where you can send stuff off and get it back. Name it. Nothing exciting there. Again, these aren't using it yet. Then we want to add a material. Now, material by default is going to use some other shader. Let's set it to our new shader that we just created. Still don't see anything on screen. Well, that's because I need to set these two things to render with the new material. Okay. We're going to make use of, that part. So let us open up. Yes, I use Model Develop. Let's go crack that open in.
You're on a Mac, so of course you're going to be using Model Develop.
Oh no, there's ways of using things like Sublime Text. There are other ways of.
Use Sublime Text for other stuff, but
It does work. It's just I keep forgetting about it half the time, so it's just easier for me to use this at this point.
How do you like the new version of Model Develop?
Hardly have noticed a difference between that and what it was. So, okay, we're going to crack open this new shader. Now, Unity, the default, gives you, there's two classes of shaders. There are surface shaders, and then there are straight up vertex and fragment shaders. Those are the two classes, vertex and fragments over here. The difference is that the surface shaders is kind of a shortcut for it. When you use a surface shader, it is a pixel-only shader, typically, and is typically designed for you're just focusing on you want a special lighting component added to an existing shader. You don't want to do anything too outlandish. It's still going to basically be realistic. It just gives you the option to do a lot more specialized lighting in your project without having to write all of the support code. It does that for you.
So this is an additional shader that would be processed prior to a vector?
No, it is
A surface shader.
a surface shader. There's the fragment shader, there's the vertex shader.
Right.
This surface shader does the job of both of those in simply an abbreviated way.
Okay.
So it's not replacing it, it's just shorthand.
So easier, less functionality?
A little less functionality. It just gives you an awful lot of extra stuff that sometimes, like what we're about to do, totally not necessary. We're not dealing with lighting for what we're about to do, so that's too much for us.
Right.
That's the difference. But it exists out there if you want to do some custom lighting, and it takes care of a lot of the grunt work for you. Very useful. But in any event, that's not what we want. So,
Can you increase the font size?
you have. Zoom in. Wow, check that out. How's that, guys?
It's better. Thank you.
No problem. Okay. So, I personally just started with a basic texture shader. Actually, I was jumping ahead a little. I'm sorry. So, I went and started with an existing shader from Unity. One that can be found, and all of these links will be available after the show. One that can be found directly off of Unity's manual. And I started with this very basic shader. It defines a vertex shader and a fragment shader. Those two are necessary when you're not doing the other version, the surface one. So, I was describing earlier about how a vertex shader flattens space. That's what this part does. Notice the return multiply the model view projection matrix with the particular point that it's being asked to check. That's what it does. That is what does the flattening of the world. In all of the special stuff that you would expect out of transforming the vertices, skinned meshes, all of that happens inside one of these vertex shaders. That's where Bent World has all of its special stuff. It's all in the vertex shader. Then there's the fragment shader. This particular one returns fragment shaders typically will only ever return a color of some type. Notice this one's using fixed 4. There's a few different formats possible. I'm not exactly sure which format is the one that is the most efficient. It depends on the hardware. I'm going to be using half 4s, I think, which is basically floating points, but instead of 32 bits per float, it's 16 bits per float. Okay, this one uses pretty standard RGBA. Not that exciting, not that complicated. All of the magic that happens is in calculating that color. Everything that is done with those ray tracing shaders, all of the work is done in the fragment shader with this giant, enormous set of methods to create one color. That's it. That's its job. Seems like a lot of work, and it kind of is. And it's quite amazing what these things are now capable of. Even just a few years ago, there were significant limits on what you could do inside these shaders. You couldn't do flow control, you couldn't do if, you couldn't use if. A simple conditional like if, not available. You had to do all of that manually. Even now there are limits on being able to use that sort of thing. So I started with that, and ours as the, I'm just going to copy, let's see, we've got the CG program. No, I don't need that. I'm going to copy in. We have subshader, so we don't need to copy that across. We do need to copy paths. In Unity, each of the shaders are built of subshaders, and then within each subshader, one or more passes, so that you can do rendering where each pass adds a little bit more to the final color. In this case, we just want one pass. Save it, head over to Unity. Oh, it's red. That is shaders at the most basic level. And as you look around the world, so strange.
You're on the game view, I think, is the reason.
Okay. Even as you go around the world, pretty boring, but they exist. They clip against the world because we haven't done anything special with depth, which is also something that you can output from one of these shaders. You can output custom depths to the depth buffer, which can be very useful in certain situations, especially if you want to only output depth. It's completely possible.
So you could have like a billboard health bar shine through a wall.
Yes. Okay. The real work is done in this CG program. This is simply a programming language that NVIDIA came up with, which is pretty much a carbon copy of DirectX's HLSL. If you do any research and you're trying to find help on using CG, almost all the time you can just find something for HLSL and it'll translate across. HLSL has a few features that you're not going to find in CG, but not much. There is the other major competitor, which is OpenGL's version, GLSL, which does have a lot of similarities. You will find some things that are just different. You cannot use those with how Unity processes them, but usually if you find a GLSL one, you can just tweak it a little bit and it'll work in CG or HLSL, unless they use some really outlandish extension. Okay, so Unity's not so smart about errors. This is what happens when you make a mistake in a shader. I did this the first time. Parse error, syntax error at line 25. Doesn't tell you what it is,
And fusion.
Yeah.
That's the color I wanted.
Now the thing
Shit.
is, no matter where my problem is, it's always going to tell you it's at the end of the shader. So if I go gobbledygook, oh hey, they fixed that. Nice. Nope. Now it's in line 11. That's not very useful.
Closer.
Not really. What you honestly need to do is make one line, save it, check it. One line, save it, check it. It's a pain in the butt, but it's the only way to actually figure out what it is that's wrong when it doesn't compile. You're just going to have to get used to it. It's a shame, but not a lot we can do about it. I do not like I like tabs. Yay, tabs. Not spaces. So, back to where we were. Yay, back to red. All right. Now, for this to be useful in our case, notice how the vertex shader is simply returning a float for the position after it's changed it. This is only enough information to draw the fragment, the triangle in the correct position. If we want to, say, draw with a texture in the fragment shader, there's nowhere for us to give that information to the other half, to the fragment shader. We have to make a structure to do so. So what I do, oh well. Unity gives you some default structures to make use of. And these are things like AppDataBase, AppDataTam, and it mentions this CG include file. It's actually really easy to find. You might think, wait a minute, where is that? Because if I just do a find on my machine, and where is Unity CG Inc. You're going to find all kinds of references to it, but you're not going to find the file. It's actually really simple. In applications where your Unity is installed, on Macs you do the show package contents. On Windows I'm sure it's going to be just within the Unity application group. CG includes. There it is. No problem, and you can open it just like any other file. It's just straight up plain stuff. And notice the AppDataBase that was just referenced by Unity. We can just as easily copy this in to our shader, preferably as another name. Vert to frag, so that we say, yes, this is the output of the vertex part, input to the fragment part, and return it. And it will do as we expect. Output dot vertex is now with the frag wasn't using any input. Now we have an input for it. And that input is currently going to be ignored, but we'll get to that here in just a second.
Are shaders interpreted or compiled?
They are compiled on load.
You return 0. Yeah. I see.
Yep, thank you for that. And because I forget to, I'm going to remind myself what I did. It has a position. Remind this. Okay. I see what I did wrong. Vert to frag. All right. Wow, I did this very wrong. I'm going to start over. This is the input to the vertex shader. We're going to create a separate structure for the output of vertex as the input of the fragment shader. I was getting ahead of myself. So, instead of a float for position, we have the full set of information. And that should probably be better. Yes, there we go. That's what I was expecting. Now we write a second structure.
Can you explain that real quick? How did Vert know how to pass in an input set?
Okay, Vert, the input of Vert is going to come from the geometry that you've submitted. These position normal text chords, those correspond to, those are the flags to say for every vertex has a list of the things that you can attach to that vertex. Its position, its normal, any one of a number of texture coordinates. Flagging the fields with its type is what the compiler will look for in order to link up what the compiler is expecting to what your code is naming. Sorry for leaving that out. Okay. So now that we have additional information coming into the vertex shader, we need to get that additional information transferred from the vertex to the fragment. None of this information from input set will be available to the fragment shader. If you want anything, you have to create a struct and pass it across yourself. And that's an important bit that gets naughty later on. Now, what can go in here? Well, you can pass a position, and you can pass texture coordinates. Almost all of the things that you can use, the only difference between the two is position can only come into the vertex shader. SV position can only go to the fragment shader, because the SV position is lerped, blended across your scan line.
Scan line?
I'm jumping ahead again. When you're rendering the actual triangle, it steps across every pixel of the triangle, and for every pixel, it's going to interpolate between the expected values that you outputted from your vertex shader. So let's say you have your triangle over here, and you've got the text coordinate starting at 0, 0, and at the other end it's texture coordinate 1, 0. Then as you go along that line, it's going to pass in a texture coordinate of 0.5, 0. So that when it reaches the other end, it's going to have the 1, 0 you were expecting. And it does that with all of these fields: the position, text coordinates, normals as well, very important. It does it with all of them. It interpolates all those fields for you. So now that I can return something real, Notice how I'm removing the SD position from here and moving it up into the structure.
What was that syntax where it has the colon and the...
Again, that's the flags to the compiler to say that this particular important piece is named pause, and this other important piece is named UV. They are standards in CG.
Right.
Standardized in CG.
It just, you can do the same syntax to the methods as well?
Yes. When you are just returning a single value, you can get away with that. If you want to do anything interesting, you're going to need a structure, however.
Oh, so it's marking the return type as being the value of that
Yes.
field. Okay.
Yes.
I understand.
Yes, and you can see that here as well.
Field and then
Right.
converting it to the return type.
Like, I think there's a depth. Could be wrong about that. But yes, you are saying this fixed 4 is the color.
Right. Okay.
So now that I've done this correctly,
We have it checked in a line or two, so.
well, actually, that's a good point. Let's undo and make sure that I did this structure correctly. Because maybe that missing semicolon, it just might do it. We don't know. And nope, didn't like it. You're right. Ah. And guess what? Shader program has errors at 11. Well, that doesn't help me. So let's see if that's it. And input set. Okay.
Okay.
Okay. You gotta wait a moment because it doesn't. When you're compiling C source file or your source files, the regular sources, you'll get that little spinner in the bottom right. You don't get that with the shaders. You just kind of have to hold your breath. Wait for 5. Okay, nothing broke. We're good. All right.
No red.
5, 4, 3, 2, 1. Save. Change. No.
Okay. So output, you got to declare it first. You can't just use it as one of those CG. It is a form of C, but it's a really rudimentary form of C. Out.vertex. Nope. Out.pause equals. And we have to return it. Oh, I wrote 3 lines. I don't know. We can handle this.
You didn't change the return type,
Yeah. Because you undid that.
and then you had the SP.
We're learning. High five, everyone. Yeah.
Well, that's
We know how to debug.
that. Honestly, that's one of my hardest things with shaders, is because you only get the final result on these shaders. Debugging these things, there are shader debuggers out there, and there's some good ones.
Wait, you can't just set a breakpoint and go for it?
No. You just kind of have to be like, well, I'm expecting this color over here if these things are true. But what if I'm wrong? Because you end up with black screen of death.
Right.
And you don't know what you did wrong, you just know it doesn't work.
It's not a bug, it's a feature. Yeah.
Yeah.
We added the blind spell shader.
Ship it as 2.0.
Now, we are going to get that input over here in the fragment shader. Oh, we changed the line. Let's make sure it works. We're good. And now, before we can really continue with the making this shader, one of the things as part of this particular one is this properties. This is where you assign, these are material-based controls. So these are controls, everything you define in this properties section is exposed as something that you can edit in the material properties. So you can make use of this one shader in 20 different materials, all with different settings for these properties up at the top. So in this case, I have a property that was given to me of texture. And another resource that came from the Unity beta tools. I have a texture, but I don't see it. Why don't I see it? We got a few things we got to do before it actually renders that texture. It is now here available in the main text, but now we've got to get it out. First things first.
Can
Texture.
you explain what that line of code is saying at the moment?
This one.
Yes.
This is saying that I'm going to name this property main text, a string, a human readable string, so I know what the heck this is when I actually look at it in the editor. Base RBG.
Okay.
The type of that texture. There are multiple types of textures. There are even multiple types of two-dimensional textures. There's cube map. There are, I think you can, I don't recall right now if you need to explicitly specify non-power of 2 textures. But there are more than just 2D textures. There's even ways of programmatically creating textures, I think. Never used it, but it's out. And a default. What it'll do if you have assigned nothing. Now, when it's in this state, the texture that it gives you will be a straight up white image.
String white was a reserved word for go get me a white.
Yes.
Okay.
And I imagine there are more than that. You'd have to Google, you'd have to go through the documentation.
Right, so that 2D is the type that the Unity shows, so if you were to rename that as, say, an int,
Well, yes, there are ints, there are floats.
right, and then it would just make the editor show
It would
an
make the
int
editor.
instead of, okay, so the editor knows 2D looks like this.
Yes, it knows that that's a texture.
I imagine the editor reflectively looks at the compiled shader to determine the type and gets the appropriate editor field type.
Actually, no, it's the other way around. This is defining the type that the editor will show.
Right. Well, the editor is going to look at the shader.
Yes.
To essentially,
Yes,
to read
that's
that
right.
definition.
And
Because it's
if
not
I did this
necessarily
right,
strictly for you.
Nope,
Because
I
these
didn't.
shaders are not Unity specific.
Right.
I assume. Because these aren't
This
Unity
part-
shaders.
this part of it, this wrapper on top of the CG program is Unity specific.
Okay.
The stuff that's in here is not. The stuff inside the CG program is not. But the wrapper is very Unity specific.
Okay.
Alrighty. And I've got this wrong.
Yeah, I think if you do it equals 2, and then that might work. Just put a 2 in.
I tried that already.
Well, yeah, put a 2 and the curlies. So that's what the other one had.
Nope. Again,
Maybe is space.
Googling is your friend.
Yeah, yeah.
You know, that's Unity is not too concerned with the spaces.
Maybe a
comma or a
colon
semicolon
at the end of the first one.
Oh well, we don't need to.
Nope, now syntax error at line 3.
Hey, that's a helpful one.
4. Alright, we're moving on. Ta-da! That was it.
You get defaulted. So now look at your.
And what?
Hey.
2. And that would now be
So
available
you got
as
rid
an
of the
input to the
curlies? That
shader.
was what it
You get
was?
rid of the default, I think.
Well, no, the 2's there. Oh.
That was.
Yeah, there's the default.
Yeah.
And what I had was
Oh, you had a colon there.
no semicolon. Oh my
How
God.
dare you?
How dare I? You know, how dare I think like a C programmer? So there you go. It's available. You can do lots of useful things with that. And again, every material can have different values for that field and still use the same shader code. Very useful. Okay, this is running a little long. All right, where was I now? All distracted. Ah, yes.
Passing it.
I need to pass you the texture. So, this is how you refer to a texture in CG. Notice it's got the same name as the property. Unity shall link the two up. Well, That just says, okay, I'm going to use that property.
So would you call this a class level field or a pass level field, or do you know the terminology?
This is everything that we're going to do is within the pass at this point.
So you call it, like if you're Googling, you call it a pass level?
Yes.
Okay.
It's not actually a field at all. This is a requirement of CG.
Okay.
So if you're Googling it, Sampler 2D, you'll find in CG documentation.
Okay.
And this is how we connect the CG side to what Unity's properties are expecting. And yay, still compiles. Okay, good. And now float. Thing. And still compiles. So now we could make use of thing.
We're going to have a blur variance here.
Notice how I am now affecting the alpha of the result based on thing. Still compiles. And when I mess with it in the inspector, right now too, well, that doesn't make a lot of sense, but I'll bring it to, oh, it's not doing what I expected it to do. Oh well. Okay, let's make it the red channel.
Hold on, thing.
It's not working. Why are you not working?
What?
Such a shame. Oh well. We'll come back to that later.
Did you? No.
Okay. So we have the texture to make use of. How do we use it? This text2D special call. You pass it the texture you want to sample from, and you pass it the UV coordinates you want to sample from. Except we don't have any sample coordinates yet. So that's not going to help us very much, is it? Let's see. How do we get those in there? Actually, it's pretty easy. We're going to pass them through UV equals input text chord, and now we're going to do something called swizzling. Notice for all of these floats is not just a straight up float. There are 4 components in there, X, Y, Z, W. I think some languages allow you to refer those directly as RGBA. Not sure if this is one of them, but you will always be able to access them as X, Y, Z, W.
Why is it W?
W is the you have to go read your old computer graphics definitions.
W short for what?
No, it's that is the perspective transformation component. Again, when you're going to have to read up on your stuff to do that, because the other components.
It says before the terms made sense.
Well, yes and no. Because all of the other components, X, Y, and Z, are divided by the value in W for pixels. No, for vertexes, for their positions. None of the other values, like position, that one is always divided by W. Normal text chord, they don't do that. But position is special in that it gets divided, and that's how we do our perspective transformations in the first place. In any event. So, I can't just do UV text chord. Just a moment, reset that. Because, oh, maybe I can't. Okay. Because text chord here is a float 4, and most of the time you get errors when you're trying to tell it to take a larger type, float 4, and put it into a smaller type, which is only a float 2, because there's only a U and a V coordinate when you do a texture lookup. In order to get around that, text Y. Swizzle. You can reorder these practically for free by using this kind of language, where you just do a dot and then the order in which you want things redone.
That's
Like,
crazy.
Yeah.
you could do ZW and get the last two components. You can do,
WX.
actually yes, you can, and get the last and first components. It's really, they call that swizzling. Very useful tool, especially because it comes for free. It costs no cycles to do that. So, XY. Did I break it? No, I did not break it. All right. So at this point, the fragment shader now knows the position and the text coordinate of that location. I can now do actual texturing. If I did that right. Why are you not changing? Okay, looks like I kind of did it too much work for Unity to handle. Let's go find out why. Whoop.
File saved?
Yep. Saved according to that. Fuse.
The texture.
Export crab. Main text. Main text. Just in case, because we're not using it. UV export one. Okay.
Return type?
Is the texture on the material?
Let's go find out.
Oh, you took off the. Oh.
There it is. Okay, well, all else fails. Restart Unity.
Maybe it's that second parameter.
That text.
There it is.
Hey!
So apparently you can overload Unity with too many changes to your shader. So if you're sitting there and you're scratching your head wondering, why isn't my shader updating? There you go. Even when I pressed play, it had not updated the shader. So, keep that in mind, everybody.
Yeah.
We've just discovered another problem with doing Unity, with doing shaders in Unity. All right.
Actually, something doesn't want to go.
But there it is. We are actually texturing those objects. They follow in. Okay, so we got that much. We're here for the warp effect. Up to this point, everything I've shown you, bent world, this shader, totally doable in Unity free. We're now crossing the line. To do this next piece, we have to have a Unity Pro. That's just, sorry, that's how it is. In order to do that neat little effect, we are going to take a snapshot of the screen and use that as a texture. Sounds simple enough, except they don't make it that easy to do parts of this. The easy part, and I'm going to just refer to my existing, ooh, everybody blind? Refer to my existing shader. The special bit is grab pass. This will grab the contents of the screen and create a texture with it, all for you.
So that just read the back buffer?
Yes, reads the back buffer up to the point the first time that this shader is used. So you want to set your shader to render as one of the very last things to be done on screen. Otherwise, you're going to, or depending on what layer you want things to draw at. But it definitely needs to be one of the last. Performance implications. It will slow down your app. You have to be careful with it, but it does work. This is not a cheap effect.
So is it copying that
that array essentially, or is it giving you reference to it?
It's giving you a reference. It's taking a snapshot of the screen and then giving you, okay, like our main text up here, it's giving you a texture that you can now sample from like a regular texture.
Okay.
I'm going to go make sure that this still compiles. Yes, it does. Because I named this thing, it is now available as a true texture, and I can sample directly from it and get something that doesn't make any sense at all. But
So it's your skybone's being picking on. Okay, now I do this.
see, we're not really able to see anything yet because we haven't set things up so that it renders something that makes sense, the UV coordinates that make sense to that texture. Also, as of this moment, the shader is rendering too early in the rendering process. And you switch back into the Unity specific stuff to tell it when to render this shader in the list of everything that it's going to render in the scene. Render type right is one part of that, and I need to find my oops. The special bit is to tell it the cue. That tells it the order
So
to render
it's
this.
essentially a shader depth.
Yes. And now it will render that last.
So is 10 an obscure value that's just higher than any other shader at the moment?
Yes.
Okay.
And overlay is a constant. Unity has a constant of overlay that represents some fairly large number. I want even over the overlays, so I just add a random number that really only makes sense within my application. So as long as you keep track of all your shaders in your application, you'll be fine.
Then,
Yes?
if you put this on this shader that's behind you that you don't see, it won't render it until the camera sees it.
That I believe you're correct because the object culling, Unity's object culling, will simply not make use of it. It won't draw the object, and since it doesn't draw the object, it doesn't use the shader. Since it doesn't use the shader, it won't take the screenshot of the screenshot for it. And notice the difference when I fixed the draw order. You can see little itty bitty pictures
Insane.
of the world.
And it's of what the camera's seeing. And
Yep.
it's changing as that's
But notice how it's wrapping in funny ways.
Yeah.
Do you remember the Global Game Jam when they did the mirror? The mirror that they
Yeah.
could shoot into and basically teleport to another location that was mirroring.
right.
That would be this.
Yeah, I think they just use cameras.
I think they used cameras to capture the tech. Yeah.
Yeah,
And then they used a shader to paint what the camera was seeing.
maybe.
I'm using the grab pass. Another way to do it is to render everything to an off-screen buffer and use that as the source of, to instead of this underscore scene, you would use that as a plain 2D texture. That's another way you could do it. One of the nice things is that Unity gives us this shortcut, which is a fairly common. We want these kinds of blur effects. We get to use this grab path shortcut rather than have to send up the entire rendering chain manually. So now that we have it displaying in there, let's fix things up so it actually looks good. In order to properly match up the texture with the screen without modification, we have to do some weird stuff where we take the position that we've calculated and pass it. Oops, not there. Not there? Yes, there. That is going to be our screen position. which is literally just a copy of the position we've calculated. Now, again, we're outputting this from the vertex shader. It's going, the fragment shader will be given an interpolated version of this value.
You're in the wrong.
Oh no, this is quite right.
Oh, that's right up there. That should be in B to F, right?
No, actually, yes, you're right. Apparently he has learned something too. And still builds. We're good. Okay. Now, remember that how I was describing, you have what actually happens is that the x, y, and z coordinates are divided by w. Because I'm copying it directly across, I have to do that manually. This is all boilerplate. To properly calculate a UV value that will match up with the texture that the screen has been taken with. So I could do, and if this goes right, they disappear. Because what it's actually doing is drawing exactly what you see over itself.
Mm-hmm.
So it looks like there's nothing there.
Yep.
And this is where it gets more fun. Now we can request, okay, I want to take from that other texture.
What is that syntax there? Screen pause star. Oh, right there.
Oh, screen pause times 5,
Oh,
times 0.5,
okay.
plus
I thought,
an extra constant of a float. And those, this little chunk right here, pretty much if you want to get it to look even somewhat right, this is what you need to start with. It's always going to be those specific constants because the texture is going to be from 0 to 1, 0 to 1, and it's going to, the position will be based on the center of the view is 0, 0. The rest of the bounding box is -1, -1 to +1, +1, always. That's what this matrix conversion does, is take whatever view settings that you've got and set it up so that everything is within a bounding box of -1 to +1, with 0 being the center. So that's always going to be the same. And still builds. Okay, so let's mess around with the screen position by taking the red part, and again, since we want to stay within the realm of 0 to 1, we're not going to move it too much, otherwise it's just going to look like a jumble. So we're going to multiply by 0.1. And notice that we're starting to see some of the offset. Well, not quite yet. X, Y, there's that swizzle again. Now it's got a little more. And it's there. Kind of. Now you appear to be looking through a very funny mirror or a very funny window.
The original textures pattern is being.
So in the case of the original game that we were reflecting, the dust game, their texture just has a certain pattern with the swipe.
Yeah.
And that's the only real difference. That is how you do ripple rendering, the long way. With the actual script, the key components, that's it. And this is what actually does the real fun stuff. In fact, we can change the amount build. Let's see if this works this time. Seeing the difference? And then because this is a field of the material, you can animate those fields as well. Like you can do a simple float animation.
Those are baked in compile time?
No, they're not baked in compile time. You can get access to that from code and change the material's what property as you run.
Awesome.
Well, thanks for sitting. Clearly you've learned a little something because you were testing it quite well.
Yeah.
Any questions?
Yeah, just the last part of code. Just that line right there. So that's taking the XY of the screen
That's taking the, okay.
wherever.
If this didn't exist, it's giving you an exact picture of the background. Then we take that position and we mess with it, add a
Taking
little
the
to it.
positions directly behind it.
Say that again?
You're taking the positions directly behind this
That pixel.
capsule.
Yes.
Okay.
And then
Adding just a little bit to it with a bit of deviation.
So that you could add just like a 0.1.
I could, and you'd see the entire screen, or that section, jump.
Okay, so yeah, okay.
can you paint outside the original bounds?
No. You have to define your model to be large enough to contain the pixels that you want to affect. That said, you can use nothing more than a flat polygon, a square polygon, and do all your magic within that. Especially if you want to, for example, if you were in a top-down view and you want your character to do an area effect that's kind of in a cone going this way, you want your polygon to be a little wider so that at the edges of the polygon, whatever your effect is pretty much nothing, so you're getting a screenshot you're getting a direct screenshot, and then you do more and more of your effect as you go inward, so that if there's a smooth transition between what you're doing and what you actually want to show them and the rest of the screen that is unmodified. So that you don't have a hard transition between them.
So you have basically a time limit to your calculations.
Not a time limit, a boundary, visual boundary. Again, let me show you that picture. He probably drew a polygon from here defined about like this. Pretty far outside of the actual what you see as being blended, so that these polys or these points aren't affected, but they still blend in. There's not a hard edge.
Right.
But at the same time, this is a somewhat expensive operation. You're doing two extra texture lookups per pixel, so you want to minimize the amount of screen space you're covering, after all. This also creates overdraw, which you want to minimize. One other piece I'd like to point out, this will only take, that grab pass will only take the picture of the frame once. So if I take these two boxes and put them in front of each other, notice how the view, you don't see the different version that you see of the capsule.
You will see multiple passes.
You don't see multiple passes, you only see it once. And that's actually a very good thing, because every time you take another picture, the background is more processor intensive. Dust, I think, uses 2 or 3 layers of this, but that program is written for desktops, consoles that have the power for that sort of thing. I'm working in the mobile space, which can support 1 phase, but that's still enough to do some very cool effects. Other questions?
Are there any good resources for pre-built shaders?
Pre-built.
Like
Existing versions of things like this?
common shaders?
No, not really, not that I'm aware of at any rate. Shaders, what people want out of shaders varies very widely between design to design. I was actually rather surprised to not be able to find such a so-called simple shader as this ripple system. That said, it took me an evening to work out for myself because I had the knowledge of how shaders worked. So it has more to do with your mindset. If you can get in the right mindset of understanding how this program is made use of, they're very easy to write your own.
Could you recommend any references for learning shaders in general past this initial introduction?
Let's see if this did what I expected it to.
All right.
Beyond that, oh yes, this one had some particularly useful information for both surface shaders and the style that we just referred to tonight, which is the vertex and fragment shaders. So there you go.
Can you show us the shader of, or the shader, the first thing you showed with the trees going off in the background?
Sure.
That was just vertex, right? No
Yeah,
fragment.
that was, well, it had a fragment shader because a fragment shader is necessary,
Right,
but what was in the fragment shader was very basic.
Okay.
So, okay. This was when I was still learning how to use this stuff, and this is what I used a surface shader to start with, and you can see how complicated it got. When all I really needed to do was set up, let's see, this is fragment surface, this is all the actual per pixel lighting, which is not the important stuff. This is the important stuff. There's that matrix multiply again, and then I call a method to twist it. Everything else, all of this, all lighting.
Your 80-20 rule right there.
Yeah, exactly. Now, what's actually in twist is a couple of constants which I could easily have moved into shader parameters, and that's it. I take the Y and square the distance from the camera and mess with it. That's all that is. Cool. All of this just so I could get those 2 lines. That's it. Notice that I also have a check for if, and those are rare, you have to use them very sparingly. That if it's only within a certain distance, I do none of this. I do no twisting at all. And if you look closely at the project while you're running it, you'll see that. Except I'm not in the scene yet. Okay. See, this is unmodified and it stays unmodified as I go into the distance until it hits a certain amount, and then you start seeing the twist as it falls off the board.
It's like that configurable.
Yep. All of that. In my initial version, I actually tried to use like sine and cosine and actually have it truly curve, but I found that this one is just as effective and was more efficient.
Right.
So yeah, there you go. All of that work for 2 lines. Okay, maybe 3 if you consider the distance.
So, if you were to do the grab pass here, would it get the version before it was twisted?
Yes.
No. Grab pass only gives you a picture of the screen at that moment. A picture of the screen, mind you. Whatever has been rendered up to that point. Nothing had been rendered up to the point of this shader in this project. So we get a white
Because the
screen.
shader renders it.
Exactly. Now, if I were to take maybe the ground and turn it back into a standard, then did a grab pass, I would get the ground in the picture, but not the trees.
Right.
Okay.
So if you had another shader, you could grab past this shader.
I really
But
kind of
it
want
would be twisted
to
because it
make
would have already been drawn.
a steep
What you
up
see
that
right here
You
is exactly what you see in the texture unmodified. So it would already be twisted, yes.
Right.
So this is a shader that you should apply when you get drunk in an RPG. Leave the ground flat and everything's falling through the ground.
That is a possibility. I mean, you can do a lot of wacky things, like let's start mode arms X. No, we can mess with Y just a little bit more.
X and Y do the opposite things.
Everything's like, nope.
Everything's curling and going down.
Or it's off to the side as it's.
Did that right.
Oh,
A little
geez.
too
You got
much.
hills.
2.
That's why.
Kind of reminds me of Conker's Bad Fur Day.
Yeah, let's make that happen for everything.
So we don't get the tear in the scene.
Is that right?
That's all right. Ask you.
It's close up, but it's messed up too.
That's cool.
Yeah.
Yeah, it makes me feel drunk just watching it.
We fell off the war.
Game over, man.
You
Game
mean it
over.
was flat?
Yeah, imagine that. With Oculus Rift.
Ah! So, there you go.
Cool.
Yep.
What else can I do for you gentlemen tonight?
I think that's good.
Yeah.
Great.
Good.
Thank you, Dennis.
Okay, suggestions for improvements.
For presenting.
Any of all of the above.
I mean, I think we interjected where we had questions. So, I mean, if you wanted to improve there, just preempt our objections.
Honestly, most of the questions you have were questions that I did not know. I wasn't sure what level of knowledge you had to begin with, and I don't want to talk down to the people I'm working with. So that's kind of why I went that route. You guys were here to learn about the shaders, so the shaders is the only thing I assumed you didn't know about.
There you go. Anything OpenGL,
not necessarily just OpenGL, but anything at that level is over my head.
Honestly, you'd
But I'm
be
not
well to
intimidated.
learn it.
It's just
The only reason that I'm capable of doing these things is because I understand how the systems work under the hood.
right.
And that's also why I see the power of Unity for what it is, because it takes so much of the grunt work out of that job for me, but still gives me the power to do those extra things when I
Right.
need them. Well, thank you, everyone. Thanks for hanging. Tell your friends.